Today we will cover 11.1, probably up to 11.3. And if we have time, we would do 11.4. But in chapter 11, now we move to statistic. And unlike probability in chapter 10, we deal with statistic in this item or in this chapter. And statistic is pretty much to be in short, statistic is just the item in math or the branch in math that you try to collect data, organize your data, and then do some testing on your data so that you can make a decision on whether you should go in and invest or should not invest, right? So that's what statistic is in short. And for you guys, in this class, we just touched the tip of a small iceberg of statistic. This is just a elementary, introduction to statistic. We will not do any conclusion or any decision based in this class. For in this class, the only thing we're doing is we will collect data, organize data, and then have a small information of the data, how to describe your data. Okay, so with that, this is what we have is the definition in statistic. We have most or everything that you deal with, we will have a data, which is the item that we want to observe, the item that we want to collect, meaning I want to collect the grade of all my students, then again, that will be my data. If I want to collect the age of my student, those will be my data. So again, data is just basically, again, what do you want to collect? And like I mentioned, statistic is just the branch of math that we would use in terms of collecting, organizing, and summarize your data, present the data, and draw conclusion. There are two things in statistic, and for us, we don't mention a lot. There are two things in statistic is the population and the sample. The population, which is the item that every item that we have in terms of our data that we want to collect, meaning the sensor every 10 years they try to collect those sensor. Those are your population. The sample is basically the individual group of item of the population. Okay. And again, the two branch of statistic you will see, I don't think they ask you, but again, descriptive statistic, and that's what we will do a lot for us, would be descriptive, meaning again, we collect data, organize, and then present to them. The empirical statistic is basically now, this is where you have to test your data. You have to take your data, put in some testing, and to see what kind of decision we can draw from those. Okay. So again, we won't do a lot of this decision making for us. We do a lot of information, collecting information. So before we do anything in 10.1 is basically we want to gather our data and organize the data. So let's say if they give you, let's say if I were to give you this data. So this data is the age of the student or whatever the age I try to collect. So the age, as you can see, between 12 to 17, 18 to 23, 24 to 29, so on and so forth. And frequency, which is how many people in that age group, right? The frequency is how frequent does this age appear. We don't know the actual age, but we know between 12 and 17, there are 3 of them. Between 18 to 23, there are 6 of them. And again, so on and so forth. So everybody see that the frequency is how many people we have in each of the group. And the class, which is the data, which is the age, this is the group of data that we have, or in the sense that this is the data that we collect. Okay, so based on this, we call this a frequency distribution table. Okay, this is your frequency distribution table in terms of how frequent does your data appear. So the first thing is, before again, I kind of give you the name in this question, and I want to ask you the question based on this frequency distribution table. So looking at this frequency distribution table here, this is the question they ask you, and this is the terminology that we will go into detail too. So this, based on this information, they ask you how many data are in the study. So how many data is this? How do we know the total number of data we have? Well, basically, that's the same question as how many people in this survey, or how many people in this study. As you remember, I told you the frequency is the number of people, which is if you add all of this frequency up, if you add all this frequency up, if you add all this number of people up, this is the number of data that we have. And based on this thing here, we don't know the actual data itself, but we know how many data there is in this study. So you can see that 3 plus 6, that's 9, 9 plus 4, that's 13, 13 plus 7, that will give you 20, 20 plus 4, 24, and again, 3 more, that will give me 27. So as you can see, the total number of data, which is the total number of frequency, which is we have 27 people in total. Those are your frequency. Those are the number of the individual data we have. Okay. So again, the total frequency is the total number of data. And in this case, the total number of data is 27. How many class are there? So as you can see, each of this group is one class. We break it down into each of this item here. So this is the class. Again, the class is just the group of data built up together. So in this case, as you can see, if you count this item here, we can see that we have 7 different classes, right? The first class is between 12 to 17, 18 to 23. So each group of data is one class, okay? So in this case, as you can see, your classes is this item here. So if we break this thing down, we have 7 individual classes. So those are your classes in terms of this thing here. So again, the number of class is different category that you have, or in terms of this thing here, different age group that we have. The total number of data is the total number of frequency. Now, the class width, this is the most, or not the most, but this is the terminology that we need. The class width is basically ask you how big is each of your class. The class width is how big is each of your class, or meaning in each particular class, how many individual, not individual data, but how many different data is in this class. Okay, so if you look at this thing here, if we dissect this elementary, do you agree that this class, the first class that I have, they tell me that I have 12, 13, 14, 15, 16, 17. That is my class. Everybody see that my class, they tell me that the first class that I have is basically the 12. This class here tell me that I have the data start from 12, go all the way up to 17. So how many data is in this group? Do you agree that there are 6 data, right? In each of this thing here, there are 6 data. Again, if we do this elementary as the same as the above, we can see that in this age group, we have 18, the person 18, 19, 20, 21, 22, and 23, right? So again, this age group, as you can see, this age group that we have, we have those many. And again, how many individual data that there is, which is we have 6 different items. So in each group, everybody see that in each group, we have 6 data between 12, include 17, there are 6 data. So one thing, a careless mistake a lot of students do, a lot of students do is this. They took the 17 minus the 12. We cannot do that, ladies and gentlemen. To find the class width, we cannot take among the class and subtract. Because if you take 17 minus 12, you say there's 5. But when you subtract, you tell me that throw away the 12. Okay? So to be in short, this is what you need to do to find the class, which later on you will see that we need to do this is you ask yourself from this class, from the first class, jump to the second class. Everybody see that the first class, jump to the second class. How many units is that? From 12, jump to 18. How many items did you add? You add 6 items, right? 12 plus 6, that's you give you 18. 18 plus 26 to give you 24. 24 plus 6 to give you 30, and so on and so forth. Meaning every time we jump from one class to the next, we add the class width, which in this case, we add 6 units, or the class width is basically, no, in short, the detail is the next number minus the previous. And again, as you can see, 17 plus 6 to give you 23, so on and so forth. Every time you jump from one class to the next class, you add 6 units, and that is how you find the class width. If not, you just count your finger, right? You just count the 12, 13, 14, 15, 16, and 17, and you can see that how big your class width is, okay? So the lower limit and the upper limit, the lower limit is basically, again, this is your lower limit here. Whatever this number, this is your lower limit, and this is your upper limit here. So if you look at this thing here, they ask you this question. They ask you, what is the lower limit of the third class? The third class, this is my first, second. My third class is right here. My third class is right here. Everybody see that the lower limit will be 24. And if they ask you for the upper limit will be 29. So again, this thing here is very self-explanatory. The smaller number is your lower limit. The upper number in that class is your upper limit. It's just pay attention on what class they ask you. So in D, they ask you for the third class. In C, they ask you for the 7th class. So the 7th class, this is what we have. This is my 7th class, which is the upper limit will give me 53. So again, your class consider of 2 things. Your class consider of a lower limit, and your class consider of your upper limit. The lower limit is a smaller number. The upper limit is the bigger number. So again, that is a self-explanatory. It's just depend on what class they ask you. So question here with the first 5 questions. Class width, each time you jump, how big is your class, or each time you jump, how many units we need to ask. So how many people older than 35? So based on this thing here, how many people older than 35? Do you agree that 36 to 43, those are the people older than 35? 42 to 47, those are the people older than 35, and 48 to 53, those are the people older than 35. So how many data is that? If you take a look at this thing here, we have 4 people in this age group, 2 people in this age group, and 1 person in this age group. So if you add the 4, the 2, and the 1, you can see that there are 7 people is older than 35 years old. Okay. How many people is younger than 23? Again, what are the group that younger than 23? Is 23 or younger, which is in this case, we have 6 people is 23 or younger. And again, 3 people here is younger than 23, which is, as you can see, there are 9 people younger than 23, or 23 and younger. Okay. So again, the frequency is the number of people, and the number of people we have is 9, because the 3 and the 6. And if you look at age, we did this before. It's just that in chapter 10, instead of ask you for percentage, they ask you for probability. So it's the same idea. Goal is what are the percentage of people in the age group of 35 to 30 to 35. So in order to find a percentage, this is what you need to do, ladies and gentlemen. To find a percentage, you need to take the number of the people in that category or in that age group divided by the total number of people in my study. So it's the same question before. They ask you, what is the probability? If I go in here and select one person, what is the probability of that person is in this age group of 30 to 35? So in order to find that age group, or in order to find that probability, basically, again, we have 7 over 27. So to find the percentage is the same. We take that item, 7 divided by the total, which is 27, to give you 0.259. And the percentage we need to convert to percentage. The probability is 0.259, but the percentage is 25.9%, or roughly 26%. Okay, so to find the percentage we're looking for, take the item that we have divided by the total item. And lastly, if we were to add another class, what would be the upper and the lower limit of the next class? As you can see, every time we jump, we add 6. So 48, we add 6, we get 54, and 59, we add 53, we add 6 to give me 59. So again, this is all that they will ask you, or this is all that they will tell you to do, is looking at this data. Can you find the percentage? Can you find the number of people younger or older? Or can you add another class in that set? Okay. So here, question with class width, question with the percentage, or question with the upper or lower limit. And again, hopefully you guys see that this thing here is very doable compared to your previous tests in terms of mutually exclusive and independent and dependent. This thing here is a little bit elementary in terms that collect your data. So let's take a look at this item here. What happened if they were to give you this raw data? So they give you this raw data. What is the information behind this raw data? They tell you that the age of the signer who signed in the Declaration of Independence. So this is the list of age of the people who signed in the Declaration of Independence, right? And now they ask you, looking at this raw data, construct the frequency distribution using 7 classes. So again, similar to the previous one, we need to divide my data into 7 different classes, and now I need to find this frequency distribution table. So the frequency distribution table, as I mentioned earlier, if you remember how the frequency distribution table looked like, this is what the frequency distribution table looked like. We have some classes and we have the number of data up here. Okay, so how do we construct this thing here? Well, before we construct this thing here, we need to know the class width. We need to know the class width. Okay, so to know the class width, we need to do this thing here. To know the class width, this is what you need to do, is you need to find a range, divide by the number of class we want. So in this case, the number of class we want, we know that the number of class we want is we want 7 classes, right? So if we have this raw data and we want to have the number of different class, this is what we need to do. We need to find a range, divide by number of class. And one thing is your number of class, you always route to the whole number. And I will mention that later. And now you probably say, well, Mr. Tran, how do you find the range of your data? Well, the range of your data is basically take the highest minus the lowest. So if you glance through this data, doesn't matter how many data we have, we look at the oldest person, which is 70 years old, and the youngest person, if you glance through this thing here, the youngest person who signed on the Declaration of Independence is 27. So the range is basically, again, from the youngest person to the oldest person, how many years apart are there, right? Which is 70 minus 27. There are 7 years apart from the youngest person to the oldest person, and that's your range is. And we will do this range later on, but again, that's how you find your range, right? If the temperature, the coolest day is 59 degrees and the hottest day is 90 degrees, what are the range of the temperature? Well, 90 minus 59 will give you 31, right? The range from the coolest day to the hottest day is 31 degrees apart. So that's your range, okay? So again, highest minus lowest, that's your range. And to find the class width, I took this range and divided by the number of class I want. In this case, they tell me I want 7 class. So 42 divided by 7, 43, not 42, sorry. The class width is 43. Because 42 divided by 7, that's give you 6. 43, my small typo is 43. 43 divided by 43 divided by 7 to give you 43 divided by 7 to give you 6.17. And like I mentioned to you guys, or this is what you guys have to do is, even though it's a decimal, and I know the decimal is smaller than 0.5. I know that the decimal is smaller than 0.5, it's not 0.5, but because of this thing here, we have to go up to the next whole number. We want to have to next whole number, no matter what the decimal is. The decimal can be 6.0072. As long as they have a decimal, we go up to 7. The decimal, if it's, you have 7.9, you go up to 8. That's easy. But if you have 7.172, you go up to 8. Again, as long as there's decimal, we have to go up to the next whole number. So everybody see that each class, the class width, each class will contain 7 data. Okay, so that's what we have is each class will contain 7 data. And again, this is what we do is once you have the class width, you start with the lowest data, and then every time you jump, you add 7 to it. And every time you jump, you add 7 to it. That will be your lower limit. And the upper limit will be 1 less. So if it's 35, the upper limit will be 34. So let's take a look at this thing here. And after that, you just tally them up. So we know that the class width is this. The class width is 7. So what is my lowest data? My lowest data is 27, like I mentioned. This is my lowest data. Every time I jump, everybody see that 27 plus 7 will give me 34. My next lower limit, 34 plus 7 to give me 41. 41 plus 7 to give me 48. 48 plus 7 to give me 55. 55 plus 7 to give me 62. And 62 plus 7 to give me 69. So everybody see that that is my lower limit. I need to find my class width. Basically tell me the class width is every time you jump from one class to the next class, how many items do you add? So in this case, the class width is 7. So every time you jump, you add 7 units. And now how do we find the upper limit? Well, the upper limit is this. It's basically, again, 34. So I need to subtract 1 to give me 33. 41, I need to subtract 1 to give me 40. Or if not, everybody see the 33, you add 7 to give 40. 40 plus 7 to give you 47. And again, so on and so forth. So everybody see that every time you jump from the upper limit or from the lower limit, from the first lower limit to the next lower limit, you add 7. For the first upper limit to the next upper limit, you add 7. So every time you jump from one limit to the next limit, you add 7. And how do we get the 7? That is your class width. How do you get your class width? You take the range divided by the number of class you want. So in this case, they want 7 class. That's where I have the 7. How do I find the range? I take the highest data minus the lowest data. So everybody see how I find this class here. Now, once you find the class, the next thing is just elementary item, which is you go in and you tally your class, right? You tally your item. So if you go in your item, you go in this individual item here. You go into this individual item here. All you do is you ask yourself, how many people is between the age group of 27 to 33? So again, 27 to 33. 27 to 33, this is what I have. 32 is one of them, right? So I have 1, 2, 3, 4, 5, 6, 7. So I have 7 people. Everybody see that I have 7 people. If I go in and circle this thing here, I have 1, I have 2, I have 3, I have 4, 5, 6, 7. So 7 people is in the age group, between the age group of 27 to 43, and that's my frequency. I have 7 individual data between 27 to 33, right? So again, that's what we're looking for. Basically, again, you can either cross them out, or however you tally them, you can say, oh, let me cancel this out, I'm using it already, it's gone. I use it already, it's gone. I use it already, it's gone, right? I use it already, it's gone. And again, there are 7 items individual. And again, you do the same thing between 34 to 40. You go in there and you tally them up, how many items you have. So again, you have 1 item here, 2 items here, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, not that, 12, 13, 14, 15, right? So we have 15 people is between the age group of 34 to 40, right? So again, 14, 41 is not one of them. So only 40, right? 40 is my limit, 41 is the next one. So again, if anything is bigger than 40, I do not include in this class. So basically you go in and you tally them up, which is you have 14 of them. And again, you go in and you tally up between the 41 to 47, you have 14 of them. And again, basically you go in and you tally them up, and this is what you have. So in the end, again, if you want to check your item, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 times 2 will give you 48, 50. You have 55 people in this raw data. Each of the number is your 1 person. So if you want to check your answer, if you add all of this frequency up, it has to be equal to 55 individual number you have, okay? So again, we know that this thing here, 10, 30, 40, 50, and again, those are 55. But again, that is the idea of organize your data, right? This is how you organize your data, because if you give your boss this data, if you give your boss this individual number up here, your boss will say, what am I looking at, right? What am I looking at here? I don't know what the number 33 or what this number is, so we have to organize them. And to organize them, this is what we want to do. We put them in some class, we put them in some group, and each group we ask ourselves how many data up here, okay? So that's your organization, which is the frequency distribution table. Question on how to find the class width, how to tally them up, and how I got this frequency distribution table. And again, compared to chapter 10, this one here is hopefully a breeze, right? It is, all of this elementary item that you have. So similarly, on top of the frequency distribution table, this is what they will ask you guys to do, is they will ask you the frequency distribution table, they will ask you to do the histogram, polygram, and the stem and leaf plot. Okay, so those are the 3 additional items on top of the frequency distribution table. So let's take a look at this thing here. So what data are they give us? The data below is the result of my Math 203 Fall 2018 Test 1. So using the table to construct the frequency distribution table, histogram, polygram, and stem and leaf plot. And now, what do they tell us? They tell us use the class width of 10. So again, this one here is a little bit easier because they tell us how big the class width is. The previous one, they did not tell us how big the class width is, so we have to find the raw class width. So this one here, they tell us to find the class width, and they tell you to use the 10-point scale. So basically, if you were to do this thing here, basically we just 10-point scale, which tell us that start from 20, go to 30, because every time you jump, you need to add 10. Every time you jump, you add 10. Every time you jump, you add 10, right? So again, sometime, ladies and gentlemen, I know you say, wait a minute, Mr. Trent, why are we not using 21 as the smallest number and you jump? Sometimes because they go by 10, sometimes the author tell you to go to the even number. You know, if they go by 5, you want to start with like, no, they would tell you start with 1 or as a whole number, or in terms of as an easy number to jump, meaning start from 20, go to 25, 25 to 30, 35, something in that pattern. Last time I did not do that because the number I jump is 7. So if they tell you, sometimes they tell you go to the next even number, or go down to the even interval, I should say. Okay, but this one here, we go regardless of how we jump. Each time we jump 10 units, right? Because of the class width of 10, just because they tell us this is what they want us to use. And because of the 10-point scale grading, we go with the even 20 to 30 and so on and so forth. So how do we find the upper limit? Well, the upper limit is basically 1 less 30, 1 less is 29, and everything in terms of that. Okay, so based on this thing here, this is what we have. And now all we do is we go in here and we tally how many students is in the 20th range, how many students in the 30th range, how many students in the 40th, 50, 60, and so on and so forth. So again, I have 121 student, right? I have 121, I have 130, right? I have 140, well, actually not 140, I have 340, right? 40, 45, 49. I have 450. Again, this is my 50 range. I have 4 of them. I have my 60 range. I have 1, 2, 3, 3, right? And the 70 and so on and so forth. And that's how you find your frequency distribution table. Question here with the frequency distribution table, which is you go in and you tally up your item, but within that class. So what is the histogram? So one thing about histogram is we take this frequency distribution table and we try to graph them. And this is the unique thing about a histogram is this, ladies and gentlemen, your data will always be, or your class in this case, your data or your class will always be on your horizontal item, and your vertical item will always be your frequency. How often does you have? Question?
Yeah, do that. Look, shoot me a number of your prices, and I'm gonna get on the phone with my people because he first.
Okay.
I'm sorry, Mr. Train. That was an accident. This Tia Sparrow.
All right. Any question here? So again, looking at this thing here, your frequency will always be your vertical item. Your horizontal item will always be your horizontal, is always be your data, or in this case, your classes. So the only thing that you need to do is you ask yourself between your 20 to 30, between your 20 and 30, how many frequent do you have? Which is, as you can see, all you do is you draw a board between your 20 and 30, your frequency is 1. So that's what you have. And the unique thing is this, ladies and gentlemen, the unique thing about the histogram is your ball will touch each other. From 20 to 30, we have 1 frequency. From 30 to 40, we have 1 frequency. And from 40 to 50, we have 3, which is, this is your frequency right here. And from 50 to 60, we have 4. And same thing we go in and we put in our frequency based on our item here. So looking at this thing here, this is the unique thing about your histogram. Your ball, your boundary have to touch each other. If they don't touch each other, meaning if your ball have a different gap, then we call that a ball graph. The histogram, your boundary, they will touch each other. And again, basically, you just tell you from 20 to 30, how frequent does your data appear? From 30 to 40, how frequent, and so on and so forth in terms of that. Okay, so this is your histogram, and you just go into your class and basically ask yourself, how frequent, how big, how far up do I have to go with that group of data? So once you have this item, the only thing different between the polygram versus the histogram is the polygram is all we doing is, instead of go with the ball, all you do is we basically ask ourselves, between this 20 to 30, how frequent do I have? Between 30 to 40, how frequent do I have? And basically you go in and you put in a dot. You go in and you put in a dot. You go in and you put in a dot. And again, basically you go into each frequency and you put in a dot. And the only thing left is you go in and you connect your dots to make yourself, or you have a graph. You probably say, wait a minute, Mr. Trent, why do you not start from the 20 and the 30? The reason being, or the reason is this: because of my class, I don't know my data is the 20 or my data is the 30. So what I need to do is I need to find one number, the midpoint, the middle number, as you will see later, the midpoint or the middle number to represent the whole thing. Because I don't know my data is 20, 30, as you can see, your data is 21 prior, right? So instead of say that, we say we're looking for one number to represent the whole class. So instead of say from 20 to 30, we take one number which is in between 20 and 30, in the number in between. So that is what I have. So again, this is the midpoint of this item here, the midpoint or the middle point that we have, and we're choosing that. And on your homework, they tell you what the midpoint is. So basically all you do is you go in, and like I mentioned, your histogram and your polygram, this is the two unique thing, is your data. In this case, your gray is your horizontal item, and your frequency will always be your vertical item. So again, you will have some vertical line and you have some horizontal line. Your data will always be your horizontal, and your frequency, the most important thing is your frequency will always be your vertical item. Okay. So you probably saw this item before. Just plug in the point and connect the dot. So the last thing we have, and I told you guys, this is the difference between the bar chart. This is the difference between the bar chart versus the histogram. The histogram, your boundary, your ball touch each other. And again, there's a small gap here, but there's not supposed to be a small gap here. All of this thing touch each other. This thing right here, as you can see, none of the ball touch each other. Is identical. It's just that they have a gap, and we call that a ball graph versus the histogram. The histogram, the ball touch each other. Now, let's take a look at this thing here, which is, this is probably the only thing that you have not saw along the way. Your histogram, your polygram, you probably saw along the way. This is probably the only thing that you have not saw along the way, which is the stamp and leaf plot. So how do we construct the stamp and leaf plot here? Well, to construct the stamp and leaf plot, this is what you need to know first, is you need to know your stamp and you need to know your leaf. Your stamp will contain the 10, your stamp will contain the one, sorry, your stamp will contain the 10 digit or beyond. If your number is big, if your number is like 117, then the 10 and beyond, which is the 10, the 1 and 0 will be your stamp, and your leaf will be the 1 digit. Meaning, again, the smallest number will be the your smallest digit will be your leaf. So just imagine that you have a branch in your tree. The stem will be some large item, and the smallest item is the leaf of the tree. Okay, so if you look at this item here, I have an example. If we have a decimal, and that's sometimes I don't say the 10 digit, but again, because the 12 or this thing here, that's your 1 digit and this your 10. So if you have an item in terms of 12.7, the 12 will be your stem. That will be your branch. And the leaf will be the 7, which is the smallest data will be your leaf. Okay, so if you look at this thing here, 136, the smallest number is the 6. Well, not the smallest number, the smallest digit is the 6, which is that is your 1 digit. And the 13 will be your stamp. Okay, so again, looking at this thing here, this is what you need to do is you need to ask yourself, looking at my data. So in this case, this is my data. It's the same data I have before. This is my data. Look at this data. What is my smallest data and what is my largest data? Hopefully you guys see that the smallest data is the 21 and the largest data is the 99. So looking at this thing here, you can see that we have a 20 range, the 30 range, the 40, the 50, the 60, and the 70. So to construct your stamp, the smallest data is the 20. So we say we start with 2, that is my stamp. The 2, the 3, the 4, the 5, the 6, the 7, the 8, the 9. And if I have 100, I have the 10. If I have 115, I have the 11, and so on and so forth. Okay. So again, this is your stamp, which is thinking term. This is your branch. And now we're looking for the leaf. What is your smallest number or your small number? So how do we do this item here? This is what you need to do is you go into each individual data. So my first data is 95. So I go to the 9, my stamp, I go to the 9 and I roll a 5. So everybody see that 95, this is how you read it. We have the data 95, we go to the 9, we write a 5. We don't write 95 because we read this thing here as 95. My next data is 56. I go to the 5 and I write a 6. And that is what I have. We call this or we read this as 56. Okay. And again, my next data, let me use this thing here a little bit easy. My next data is 87. I go to the 8 and I write a 7. I go to my 8 and I write a 7. My next data is 49. I go to the 4, I write a 9. And my next data is 83. I go to the 8 and I write a 3. So everybody see my first 5 data. My first 5 data, everybody see that's where my first number. I have a 95 data, an 87, an 83, a 56, and a 49. So those are my first 5 data. Everybody see where my, and again, when you have this 2 number, each of them is one individual data. So we have 87 as one data and 83 as another data. So again, that's what you read. When you read this thing here, you read 87 and you read 83 as each individual data. Okay, each number on your leaf is one individual data. So first of all, question here, ladies and gentlemen, how I got the first 5 number in here and where my first 5 number disappear over here. And the same thing go, you go to next set of number. We have 76, so we go to the 7, we write a 6. We have 73, we go to 7, we write a 3. 55, we go to the 5, we write a 5. 21, we go to the 2, we write a 1. And 90, we go to the 9 and we write a 0. So again, this next 5 number, those are where my number come in. I have a 21, I have a 49, I have a 55, I have a 73, I have a 90, right? So again, those are my data, and same thing go, we just go in each of your data. You go in each of your data, which is the next data. We have 80. So my 8, I wrote 0. 82, I wrote a 2 on my 8. 75, 71, 63. And then 45, 59, 67, 84, and the rest of the item. Okay, so again, this is what we have. And if you look at this thing here, if you count the individual item, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. You have 25 data here. You have 25 data in here. So we finished every single number that is in my raw data, and I put them in the stamp and leave plot. Okay. So again, this is what we need to do, or this is how your stamp and leave plot should look like. Your stamp, in this case, your stamp is the 10th digit, and your leave is the 1 digit. So question here, how to take this data. This is your goal. You take this data, this raw data, and you put in this stamp and leave plot. So what is the unique thing about stem and leaf plot? Why do we go in trouble to find the stem and leaf plot? If you look at this item right here, ladies and gentlemen, if you were to look at this item, if I were to draw this box, and if you see this item right here, if I were to draw this box this way, you could see, or hopefully you guys see, that this is the same as your histogram sideways. Okay. If you were to take a look at this item here, and to go back to this item we have, if you were to take that item and to go back to this item we have earlier, everybody see that all I did was, this is the same histogram, turn it sideways, right? This is the same histogram. If my histogram is right there, and this is basically, if I turn it clockwise or I turn it upside down, it's the same as my histogram. Okay, so you would say, well, if the stem and leaf plot is the same as a histogram, what is the unique thing about stem and leaf plot? Well, the unique thing about stem and leaf plot is you can see the actual data in your stem and leaf plot. If you look at this histogram and I ask you how many students score 75, you would say, well, Mr. Tran, I know that from 70 to 80, I have 5 students. From 70 to 80, I have 5 students, but I don't know how many students out of the 5 students score 75, right? So if you look at this thing here, we don't know how many students score 75. And that's the unique thing about stem and leaf plot, ladies and gentlemen. The stem and leaf plot, if you look at this thing here, and let me go to this thing here. If you look at this item, we know exactly how many students score 75, because we know that 75, we have 2 students score 75. And that's the unique thing about stem and stem and leaf plot is, if I ask you how many students score 85, you would say, no, there's no student score 85, Mr. Tran. There's 80. There's 1 student score 80. There's 1 student score 82. There's 1 student score 83. There's 1 student score 84. There's 1 student score 87. I don't have any student score 85. And that is why the stem and leaf plot work. Yes, it's the histogram sideways. But with this sideways histogram, you know the exact score. You know the exact data, and not just say, oh, I have 5 people score between 80 to 90, but I don't know the actual score. You have 3 people score, you still know that there are 3 people score between 90 to 100 or 90 to 99. But now you know the actual score. There's 190 student, there's 195, and there's 199, right? You have 1 student score 20, but how low is this 20? Is this 29? And again, as you can see, this is 21, right? We have 1 student score 30. Is it 35, 37, or 39? As you can see, with this stem and leaf plot, we can see that there is 1 student score in the 30 range, and the actual score is 32. So it's the lower 30, not the upper 30. Okay. So question with this stem and lib plot, what the use of this stem and lib plot, or how to construct the stem and lib plot. So once you have this thing here, once you have, and again, that is 11.1 in terms of organize your data, construct your data, and you know, present your data. 11.1, 11.2 is that. 11.3, this is what we have, is we want to measure. Now, once you have your data, we want to know what is the middle, of your data, what is the center of your data, right? So in this case, how do we know the middle of your data? Well, there are 3 or 4 items that you need to do to find the middle of your data. And you all saw this item before, which we need to find the mean. And again, the mean, before they ask you the average, now they changed the word to become a mean. We need to find a median, which is the median is the middle position of your data. We need to find a mid-range, and then we need to find a mode with the assumption the mode is basically the most data is sometimes is the middle of the data. So this is what we have, is we need to find this 4 items. So how do we find the mean? Well, the mean, like I mentioned, is the average of the item. So all you need to do is you add each of your individual item. You add each of your individual item and divide it by the total number of items you have. So basically, if you ask me, Mr. Strand, what is my test average? Basically, you find the mean of your test grade. All you need to do is take the test, the point on the first test, add it to the point on the second test, add it to the point to the third test, and divide it by the total number of tests you have, which is in this case, you have 3. So you add each of them. Oh, we have 4, right? So you take each of your tests, add them together, and divide it by the number of tests. So take each of the score on your first 4 tests and divide by 4, and that is your average, or in this case, that is your mean. To find a median, this is what you need to do, and the most important thing for the median, ladies and gentlemen. The most important thing for your median is your data have to be in order. It will be either from the smallest to the largest, or from the largest to the smallest. But regardless of what you do, your data must be in order. So once your data is in order, there are a few things that we need to do. We need to know if your data is an even number of data or your data is an odd number of data. If your data is an even, well, let's do odd first because odd is easy. If your data is odd, then whatever the middle number is, that will be your median. Okay, so if your data, meaning if you have 5 data, then you put them in order and the data is 11, 17, 21, 32, 54. Then the middle number is 21, that will be your median. Okay, if your data is odd, the middle number is your median. If your data is even, a little bit different in terms that if your data is even, what do we need to do? We need to find the middle 2 number, add them up, and divide by 2. So for instance, if my data is like before, 11, 17, 21, 32, 57, and 100. What I need to do is I need to take the 21 and 32 because I have 6 data. The middle 2 is 21 and 32. I need to take that 2 number, 21 plus 32, to give me 53 and divide that by 2, which give me 53 divided by 2 to give me 26.5. So 26.5 will be my median. Okay, so again, that is what you need to do. And the median is just, to be in short, the median is just the middle number. So again, in order for you to find a middle number, you need to ask yourself, do I have the odd number of data or the even number of data? If I have an odd number data, the middle number is the median. And if I have an even number data, I need to take the middle two, add them up, and divide by 2. The next two, the mid-range. The mid-range is basically, again, the mid-range is the same as midpoint, is the same as mid-segment. Whatever they ask you for mid is the same. How do you find the mid-range? Well, the mid-range is basically you take the lowest data plus the highest data, divide by 2. So again, the mid-segment or the midpoint is basically you take the lowest point, add to the highest point, divide by 2, right? So if you tell me miss distance, right? As long as they ask you for the mid, is basically, again, if you know what is your mid range of your test. So if you take 65 plus the 90, again, 65 plus a 90 to give you 155, divide that by 2. So 155 divided by 2, you will see that you have 77.5. 77.5 will be your mid range. Okay, so again, the middle of the range. So that's what we have to do to find mid range. And again, the mode, there's no, for this item here, there's no calculation involved. The mode, all you need to do is you look at your data, and you ask yourself, is there any data appear up the most time? Whatever appear up the most time, that will be your mode. Sometimes you have a bimodal or trimodal if you have 2 mode or 3 mode. Or sometimes if your data does not appear multiple times and they appear the same amount of time, you say that there is no mode, right? There's no data appear up the most, okay? So looking at this thing here, question with this 4 item, the definition of this 4 item, the mean, the median, the mode, and the mid-range. So let's do one problem before you guys go. Let me see. Let's do this item here. So again, this thing here, we will continue this next time, which is section 11. Let's say we have this item. How do we find a mean? How do we find a median? How do we find a mode? Or how do we find a mid-range? And we can stop after that. So let's remind us again, the mean is this item here, the summation, add all of your value up and divide it by the total value. So this is what they give you. As you can see, this is your frequency distribution table, or your table, not frequency, because they give you different rate. So this is what they tell you, that the 12th state with the highest unemployment rate in the United States in May 2016, and their rate of unemployment is given below. Find the mean unemployment rate for this 12th state. So to find this mean, as always, or as you can see, what do we need to do? We need to take each individual rate. We take each individual rate divided by the total number of states that we have. So 6.8 plus the 6.4 plus 6.2 plus 5.8, so on and so forth. If you take all of that, you add them up to give you 67.8. You can check my math. Sometimes I have a typo here and there, but again, 67.8, we divide by the total number of states, and in this case, the total number of states is 12. So given this thing here, 67.8 divided by 12, you will see that the average rate of this, or the mean rate of this 12th state, is 5.65. Okay, so again, somewhere in between, somewhere in the middle, right? They are 5.2 and 6.8. So as you can see, those are your range, right? From 5.2 all the way to 6.8. Somewhere in the middle, 5.67 is the average, the middle of that rate. Okay, so question with this mean, the average number. And once you find the mean, now what about find the median? How do you find the median of this item here? Well, the median of this thing here, first of all, do you agree that, first of all, they give us in order? They give us in order. In this case, they give us from the largest to the smallest. And like I mentioned, make sure that to find a median, do not jump the gun and just look at the middle number. To find a median, the most important thing you need to do is you need to put your data in order. And in this case, your data is in order. How do you find the median here? Because we have 12, which is your even data. Because we have an even data, we need to look for the middle two number. As you can see, if you cross this number out, cross this number out, cross this number, cross this number, cross this number, cross this number, if you make your way toward the middle, you can see that you cannot cross, well, technically you cross this two number two, your median is somewhere in between this thing. But again, if you make your way inward, you can see that because it's an even number, we left with 2. And because it's even number, they tell us we need to take this two number, 5.3 and 5.4, we need to add them up and divide it by 2. So if we add them up and divide by 2, as you can see, the median is somewhere between this two number, and that is where my median is at, which is right here, 5.35. Right, somewhere in between those two numbers. And this is what the unique thing about the median is. The median, they are symmetric. Everybody see that I have 5 data, or in this case, I have 6 data on the left and 6 data on the right. My median is in the middle position, and that's where my median is at. Okay, so this is how you find your median if you have an even data. What happened if you have an odd data? What happened if they give you this thing here and they ask you to find a median? And again, hopefully you can see that we have, why we have odd, we have 2, 4, 6, 8, which is 2, 4, 6, 7, sorry, not 8. So if you look at this thing here, please, ladies and gentlemen, do not jump the gun. Do not say 43 is my median for this data, okay? The careless mistake is easy, but the careless mistake people do is they jump in and they say 43 is my median, but it's not. Why it's not? Because in order for you to do this problem or to find a median, you need to put them in order first. You either put them in from smallest to largest or largest to smallest. So in this case, you need to arrange your data in order. And once you arrange your data in order, everybody see that the middle number, because it's odd number of data, the middle number is your median, which in this case, the median is 24. And that's a careless mistake a lot of students do. Even though it's easy, but there's the easy problem come with the careless mistake. Okay, so make sure your data in order before you can identify your median. That's the difference between the odd number versus the even number. Question with this median here. So once you have, if you don't have a question with your median, this is very easy left. The last two items we have is the mid-range and the mode. So to look at this thing here, to find the mid-range, looking at this thing here, reminder, mid-range is you take the highest plus the lowest, or the lowest plus the highest, divided by 2. So we have the lowest is 5.3 and the highest is 6.8. So my mid-range, I take this divided by 2, my mid-range is 6. Okay, so if I add them together, I get 12 divided by 2, I get 6. So the middle of the pack, the middle of the range is 6. And if I look at this thing here, what about my mode? To find a mode, everybody see that this is the item that appear up the most is 5.3. And in the same token, 5.2 appear up the same amount of time. So again, this thing here, your mode, you have 2 of them, which we call this a bimodal. You have 5.3 and 5.2, they appear up the same amount of time, but the most same amount of time, which is 3 of them. And that is your most item that appear. And again, because they appear up the most, that is your mode. It's just that in this case, we have 2 of them and we call this a bimodal. If we have 3 of them, we call it a trimodal. If we have 1, we say the mode. If we don't have any, we say no mode. We don't have any mode. Okay. So given this thing here, question here, ladies and gentlemen, how to find your mean, your median, your range, your mid-range, and your mode. Any question here, ladies and gentlemen? Well, if you don't have question with those, let's stop here for today.